Good afternoon. I am Sohadya and 19 BC 1330 registered under Professor Dr. Premalatha in NLP. Dr. Premalatha's slaughter of E1 plus T1 and I'm doing my J component review 1. I'll give you an overview of NLP. So about language technology, I'll give you one example. He's bored. He's bored and he's not bored actually. He's sick of the dog going to the garbage, so he's ordering him to stay out of it. So there is context and there is structure of a sentence. Just stay out of the garbage, a clear order meant for the dog to understand. Well, that goal, that's what we think the dog will understand, will take into it. Noise coming out of him. There would not be a lot of space for success for that. There'd be a lot of limitations between the communication. So I'll give another example. This and in this case, Hal is the AI, Dave is the man, and you can see they both are having a conversation, and it's both in English, and it's very polite, and both can even understand each other. So this was way ahead of its time that a movie was showing kind of intelligence which was not there at the time. Maybe not even at this point of time, but I can tell from the tone of your voice you're upset. So it can tell you. So it's guessing from the tone of its voice, which means the emotional capability or the emotional understanding of the AI is extremely high. I'm sorry. So it continues the conversation on that. So that is a level of intelligence that's not been shown by any other person. There's no need to feel in. As I said, recognition of emotion from speech, the visual recognition. It's, it's not even doing it visually. It's just listening to him and telling him. Just situational ambiguity. It's so simultaneous. The conversation goes on, but in this case, there's a protocol problem. So, this is modeling. It's way ahead of its time. In 1968, it's 2020. I don't know. There's not so much department. So, so this model of self, including goals, of agents in it, text meaning, intention, all these issues, and the way it goes. We could try to fake intelligence like this, but to maintain dialogue at this level, just from seeing, just from maintaining ambiguity, and just from emotional intelligence, that is so hard. Well, that is tough, but do we need it? Maybe sometimes. So NLP is field and part of AI. It's devoted for creating computers that use natural language as input and output. So as you can see from the diagram, it's taking in the input and giving it the output. It's trying to understand the NLU, natural language output, sorry, natural language. The processor is the one which is processing it, hence the process being natural language processing, and then the generation, the NLG. In this case, is a field that uses its own computational methods. Investigation could be taken as analysis at this point. It'll take the properties of an human written language and try to model its own mechanisms, own cognitive mechanisms in its own processor, in the that in its own output. Now I've explained so much, but I could give it to you in a nutshell. So natural language is absolutely a language spoken by people, like the one I'm speaking now in English. It could be Hindi, it could be German, it could be Tamil, it could be anything. As opposed to a language which is normally like C++, Java, anything which is there, which has been spoken linguistically. Now, linguistic will be the study of language and its structure, the study of grammar, syntax, and phonetics. Linguistic could include social linguistics, dialectology, psycholinguistics, computational linguists, comparative, and all. Those are all branches of it. With the main points being the specific study of language and its structure, the study of language with its structure. The branches of it which I checked. Now, why NLP? Why am I talking about NLP? NLP is normally used to interact with computer devices, as we checked earlier. It will take the input and give an output in the human natural language, for example, built-in and robot, and enabling and voice control operation to access information. As I showed in the dog human case and the Hal David case where the Hal was an AI. So yeah, there's a conversation going on, and you need a voice control operation which you do in your daily life, like Chatbot when it gives you recommendations, which is an example. So these are all amounts of information which we are giving out, but it's in the form of a human language. So to process it, which is that. So these three parts the NLP is used. One is spam detection. So I'm depicting the progress of how NLP has done. In spam detection, NLP has mostly solved the problem, the part of speech tagging. ADJ is an adjective noun verb. So verb as it's going on in its power of speech also mostly solved. And is named in entity recognition. It will same as power of speech tagging. It will tag what kind of entity it is. In this case, it's tagging a person, an organization, and a location. So it's tagging three things. I'm sorry, whether it's in person, organization, and a local state. It's almost solved, and we have been doing good with it. And for the good, all making good progress part, sorry, I'll make it bigger. So sentiment analysis. In this case, it's analyzing the words. Both are not the same words. And in this case, conference resolution, word synthesis, ambiguation, parsing, machine translation. It's doing well in order. Information extraction has been making good progress, but with complex kinds of messages, it tends to make some kinds of problems. That's why it's not completely solved yet. But for normal regulatory messages, it's doing quite well. It extracts, suppose in this case, is an event marked May 27. So how effective was ibuprofen reducing? So this could be a complex question for the computer as not for doctor. So if you type this in Google, Google could give you a lot of things recommended, but it won't give you the exact information you need. There'll be a lot of rambling around for that. Paraphrasing is also not done completely, as you could see in the statement. The regulatory statements are doing fairly alright, not as well as information extraction, but doing fairly alright. But if it's a complex statement, then it won't be able to summarize properly. So, next. Some applications could be finding some documents from database of text extraction, as we showed earlier, which is making good progress, of course. Translating documents, of course, machine translation, automatic manuals in some languages will make Japanese. They are a bit complicated, but for in this case, it produces a 3-page summary of a 100 page, 100, it's actually 100 page report. Could do that if the statements are not that hard enough. Question answering systems could be query database, could put a query about some catalog. Online tutoring systems could also be where I could search for NLP, anything related from NLP, and I would get different website links for that, or any videos related to that, any YouTube video that could teach me, help me. Voice control is also a model now. A voice control where you could ask something and just now if we put some applications examples like a computer program in Canada will take in data and automatically generate weather reports in English and French. So it's translating it, it's taking the data and giving out in English and French. As Canada is an English and a French country. Anyways, there are about 1 million translation requests posed by the Babelfish system, which is present in Alta Vista. Can also ask the computer about places to eat in any spoken language the computer understands, and the system will check through and it will give you. So if you're a tourist, this could be important. If you're stuck in a place, in this case Cambridge was taken, so you ask if you're stuck, and with your language you ask where your places you need to eat to your phone or your computer. This could be another type. Now computer, this could be one of the problems where computer will create some essays or some parts which student may be right, but it could get indistinguishable and it may give you a wrong even though it is not. Now a computer watches a video clip of soccer game, it may or may not give you the right report. It will properly. People who have dyslexia or disorders who don't communicate words, so it uses a prediction system where it predicts upcoming words and expands abbreviations to help them. Now for the challenges. So people have no understanding in natural language. The ones who know, because yes, if I'm speaking in English, so I would speak to somebody who knows English, or if so the goal of the NLP is to go beyond just string processing or keyword matching. There are some hidden variables written. Now the main problem being the problem scale. There are infinite words, possible words, and the list keeps on increasing. So there's no limit to it. And for such, these are all the layers of NLP. Phonetics and phonology. Language sounds, you study them. Ecology, you study of language conventions for punctuation, text markup, and encoding. Morphology, you study the meaningful components of words. Relationship among words, they check for it. Semantics, as it means lexical writing. In this case, word. So just take the word meaning, study it. All through time, the meaning changes a word or how it came to that. Composition, semantics, which will always be meaning. In this case, compositional sentence, lexical was word, so this should be the sentence's meaning. Sentences. In this case, the convention of dialogue. So it extends beyond a sentence. Collection of them. That's what a dialogue is. So there are 6 levels, as I said. Speech sound will be phonetics, words and their forms. Morphology, lexi. Lexi is always words. So morphology and lexi will come together. Morphology is meanings. Study of the study of the components. Sentences in this case will be compositional. So semantics will always be meaning. Level 5 meaning in context and for purpose will be pragmatics. This pragmatics will take the meaning in part for situational context. So it will find a situational, so it will find the meaning for the word which when where the situation it will fit in properly. Connected sentence processing a larger body of. You can see about phonetics, which was the study of the sounds, and individual speech units, which is phones. Phones being the speech units in this case. You can see the phones, diphthongs, diphthongs. You can see the consonants, vowels, and diphthongs. So, I, B, C, house, B, C, beach, and then the big, how it's pronounced, all same. Now, for tokenization, I'll take a depth side to explain what is it. Morphological, as I said, will take an component of a word and explain it. Syntax and parsing, as usual, it will take the relationship between a word and it parse it. So part of speech tagging, which will come with this. I'll take another slide for that. Semantic, as the word which will fit in that situation. Another will be comprehending the intention meaning for a dialogue or more than sentence. Knowledge based reasoning, as I said, the 3 things needed for that are the knowledge of language, knowledge of around the world, and then a text, which will be the final part. So, as I said, tokenization morphology. A period after Mr. isn't in sentence break. As you say, Mr. XYZ, that period after Mr. won't be a end of a sentence. Now there are tough things to understand. Suppose if you take this language, it's a bit harder to understand because it's a language we do not know. Now for morphology, segmentation being the meaning of the word, there are two types: lexical composition. As you can see different types of words, and that are Spanish. There are all those types of words. Discourse, as I said, how do sentences relate to each other? How do the meanings correlate to each other? Pragmatics is more related to a situational. How should you react to it? Phonetics, acoustics, and physical production of sounds. Phone, as I said, the smallest unit. Phonology, how sound patterns in a language. Now, for taking tokenization, I took it definitely in a part because it's an important. It's one of the initial parts where you are breaking up the text or the words in small parts called tokens. If there's a big one limitation, because in Japanese, as you saw in this language, now tokenization is very tough, very hard to do it that way. End and point of a word and beginning of the word is called a word boundary. So as you can see, this word ends here, this word starts here, so there's a boundary there, the word boundary. Now this could also be called word segmentation. In this case, you break a string of characters or all so-called graphemes into a sequence of words and sentences. Words will be separated by space in sentences, similar to tokenization by boundary markers. But limitation again, there are more than one sentence boundary marker, semicolon, exclamation mark, question mark, all these types. Morphology, as I said, to study the relation between words, to study the important components of words. English, it means and when I met you in a masculine form. So it will study the important parts, the components of this. Syntax will take the relation between all, so you could see all of them. Power of speech, tagging, parsing comes in this. Now if you take any sentence, in this case I like to read books, so it's power. Then there are tags, all these kinds of tags, adjective, noun, phrase, so it's annotating each word in the sentence. And some syntactic parsing, there's a disambiguation, which is like distinguishing between things, so we could interpret it properly. And certainly this and natural human language, formal programming languages are very ambiguous, which are Java or Python, which aren't natural languages, but formal programming languages are very ambiguous. They have a grammar. They have a very context-free language, which means that they are unambiguous and they are defined by one grammar. So it's one jargon they've used, and there's a unique parse which for the sentence in that language. So how it deals. There could be a formal approach, very coupled and interaction among processing levels. Knowledge has to be gained, so it could decide among the choices where the ambiguity occurs. Pipeline processing, where the ambiguity could be ignored, and the hope that the other levels above could eliminate it. Probabilistic approaches are predictive approaches with the most likely choice. Now the NLP cycle, you pick a problem. I'll summarize it, which is also one of the applications of NLP. This is very effective. You pick the problem, you distinguish it to interpret it, you get the data, you put it in a corpus. Now I'll explain what's corpus later, but to explain to you, it's a resource of a set of could do to avoid them. You modify the system absolutely according to them. You engineer the features, the presentation, absolutely like that. There could be different machine methods for that, and doing it again and again and train it again and again with different problems. Absolutely. Summarization, as you can see, part of NLP condenses the information. There's so much going on. It's putting it on, and this is an example analysis generic process it. Translation, as you could see, machine translation. There's one problem. Since in this case tenses, I'm sorry, it means tenses. Lot of tenses, so a lot of possibilities. Event extraction is one. Event extraction, as I said, was a mostly good enough thing. In this case, it takes an event. I wanted to explain this part as an application because so this is pretty good, almost good enough application which has gone a long way. The specific occurrences, so in this case an event trigger, there will be a word which will trigger it, which will express the event occurrence. The argument that mentions that you're involved in an event as a participant is in mention. Get an mail about an event, the calendar automatically linked to that email saves it, and if the time is given, it will save it accordingly with the name or the email or the title, whatever, which is very advanced. It's something people have been I didn't know about. I suppose now people do. So the key terms are needed. Corpora is bigger than the corpus. It's a collection of corpora. Corpora is the collection of corpus. I'm sorry. So as I said, plural form of corpus. Corpus, the language of structured set of text from which the data you take. Corpora is the collection of it. Bilingual corpus, sometimes the documents could be written more than two languages. Multilingual, more than two documents having two or more bilingual multilingual corpus, and a collection of it corpora. Talking to me, that free dialogue, n-gram, n tokens, semantics, meaning as usual, linguistic meaning. Token, for any processing to be done, it needs to be segmented into units such as words, with punctuation, numbers, alphanumeric. The small units are called token. Sentence, an odd sequence of tokens. That sequence, that's an odd sequence of tokens, all said delimitation, the white space in English kind of makes it easier, the word boundary between the end of the last word and the beginning of the next word, which makes it alright. But for languages like Chinese, Arabic, tasks become a bit more difficult as there are explicit boundaries separating them. So that's it. Thank you very much. You've been very kind to listen to this, and I think I've come to the end of it. It will be about a movie recommendation for laptop, or movie recommendation where the chatbot will recommend different movies to you. I'll give a brief idea about it in a Word document as I'll go through. For now, I can say this much. It will be very flexible. It will be in Python actually, which I'll try to create as a web app, and which I'll use. So that will display an error, and it will only answer according to the specific requests that will be there. Some advanced algorithms will be used. I'll write a bit about it in the Word file. I'll be linking the YouTube link too. So thank you for listening, and good evening, or wherever you are. Thank you. Bye. End of recording.